Welcome to the story about cell energy. The goal is explaining how cells make ATP. It happens in the mitochondria, which you can think of as the cell's energy factory. Mitochondria are double membrane organelles, an inner membrane and an outer one as well. The mitochondrial matrix is the fluid inside. It's where reactions like Krebs cycle reside. Glycolysis and Krebs make NADH and FADH2 from energy and food. These electron carriers make their way from the matrix to the inner membrane. And that's where you find the electron transport chain. It's a series of enzymes embedded in the membrane, which take the electron carriers' electrons and uses their energy for pumping protons. The mitochondrial electron transport chain uses electron energy for pumping protons from the mitochondrial matrix to the intermembrane space, increasing proton concentration in that place. The only way the protons can escape is through a channel and an enzyme ATP synthase, which uses diffusing protons' kinetic energy to make ATP from ADP and P. The chain is a series of enzymes in a row. Each accepts electrons and lets them go to the next carrier in this transport chain. It's kind of organized like a bucket brigade. What drives electrons down this enzymatic series is the growing level of each carrier's electronegativity into oxygen. Electrons ultimately fall. It's the most electronegative of them all. It's NADH that starts this run, donating electrons to complex number 1. This powers active transport as protons are displaced and get pumped from the matrix to the intermembrane space. From complex 1, electrons flow to ubiquinone, also known as Q, which floats through the inner membrane happily and brings its electrons to complex 3. And you can guess the function of complex 3. It's another proton pump using electron energy. Protons jam up in that intermembrane compartment like 100 people in a one-bedroom apartment. The mitochondrial electron transport chain uses electron energy for pumping protons from the mitochondrial matrix to the intermembrane space, increasing proton concentration in that place. The only way the protons can escape is through a channel and an enzyme ATP synthase, which uses diffusing protons' kinetic energy to make ATP from ADP and P. Complex 2 is for FADH2, which donates electrons, which then get passed to Q, which once again passes them to complex 3, which pumps protons using electron energy. From complex 3, the electrons proceed to another mobile carrier, cytochrome C, which donates the electrons to complex 4. Another proton pump, could you ask for more? After complex 4, electrons flow to oxygen, which is ever so electronegative. It pulls electrons down the chain, keeping them moving like the cars of a train. And NaSO2 does this electron grabbing trick. It also grabs protons from the matrix. They all combine to form H2O. Electron transport chain, watch it go. The mitochondrial electron transport chain uses electron energy for pumping protons from the mitochondrial matrix to the intermembrane space, increasing proton concentration in that place. The only way the protons can escape is through a channel and an enzyme ATP synthase, which uses diffusing protons' kinetic energy to make ATP from ADP and P. Now all these protons in the intermembrane space are trapped. They can't get out of that place, cause protons are charged and could never get through a phospholipid bilayer. They can't diffuse, but like all particles, they're dying to go from where the concentration's high to where it's low. Stuck in the intermembrane space, they're frustrated to diffuse to the matrix. They're highly motivated, and this gradient's been made steeper by O2, which absorbs protons from the matrix stew. So from proton pumping and oxygen's actions, add another force, electrochemical attraction. Think of all those trapped protons, each one's positive. The matrix in comparison is negative. Opposites attract, so the protons are dying to get to the matrix. Oh, how they're trying. There's only one channel that lets protons pass, and they use it like high school students busting out of class. It's a channel and an enzyme. It's ATP synthase, the closer in this game, an energy ace. ATP synthase is embedded in the inner membrane. How it works is so cool, it's insane. It's got channels for diffusing protons running right through it. When cells make ATP, well, watch how they do it. The matrix side of ATP synthase has binding sites for ADP and P, which come in and bind. And as ATP synthase lets protons barge through, their kinetic energy gets put to use. Like water through a turbine, proton movement generates rotation, changing synthases, binding site conformation, which catalyzes chemical bond formation. ADP and P make ATP that energy sensation. The mitochondrial electron transport chain uses electron energy for pumping protons from the mitochondrial matrix to the intermembrane space, increasing proton concentration in that place. The only way the protons can escape is through a channel and an enzyme ATP synthase, which uses diffusing protons' kinetic energy to make ATP from ADP and P. The mitochondrial electron transport chain uses electron energy for pumping protons from the mitochondrial matrix to the intermembrane space, increasing proton concentration in that place. The only way the protons can escape is through a channel and an enzyme ATP synthase, which uses diffusing protons' kinetic energy to make ATP from ADP and P.